Hi everybody. Today's objective is 7.3c and this is the last objective for unit 7 when we're dealing with degrees. Next we will be moving into radians to measure angles. Okay, so the topic today is reference angles and the calculator. You know that the other day or yesterday we made a unit circle, and the unit circle had the special right triangles embedded in it. And we created all the 30-degree reference angles and 45 and 60, as well as the quadrantal angles. Well, today we're going to look at angles that are on the unit circle and then angles that are not. And so when angles are not, we have to revert to the calculator, whether or not 30, 45, or 60 degrees. Okay, so our essential questions is how do I use reference angles to find trig values? So I'll know the angles. I'll know the angle measure, what's its trig value. How do I use a calculator to find approximate values and angle measures that are not acute? Okay, so first I just want to make I just want to really define reference angles. So we're going to start with this. Reference angles denoted as theta sub r. And I think I'm going to highlight that. Thusly, okay, are formed by the terminal side of theta. I'm going to highlight that in pink, I think. Okay. I think I'm going to make my highlighters a little skinnier here. Okay. And the x-axis with the vertex at the origin. They are always acute. So greater than 0 but less than 90. Okay, and then what I would like to talk to you about is how you find these reference angles when you're in the different quadrants. So let's look first at quadrant 2. So here we have our x, y, and let's say we have angle theta that goes like this. So here's angle theta. I'm going to highlight that. Okay, and this is 0 degrees, and this is 180 degrees, and so theta's reference angle is this measure here between the terminal side of angle theta and the x-axis with the vertex at the origin. So in quadrant 2, if you take 180 degrees minus angle theta, you will get theta reference. And you know, a little bit of common sense goes a long way. A lot of times when you're doing these, if you'll just draw the angle on the terminal side and then just look at the distance from the terminal side to the x-axis, and that's going to be a reference angle. Now sometimes it's useful instead to take 180 degrees and subtract the theta reference, and that is going to give you your theta. So I'm just going to go back and highlight those. So that's useful information that we're going to use in a little bit okay, in quadrant 3. So I'm going to draw a little bit different picture here. Well, 0 degrees, 180 degrees, 270 degrees. Okay, and so if we have an angle theta that does something like this, then theta's reference angle will be here. And so I'm just going to highlight theta, which would be this angle here, versus theta's reference, which would be that angle there. Okay, and so in quadrant 3, if you do theta minus 180, it will give you theta's reference angle. Or if you have theta reference, if you know what it is, and you add it 180, it will give you the measure for angle theta. So I'm just going to go back and highlight those. Okay, so those are useful pieces of information for quadrant 3. In quadrant 4, so we're going to come around and end in quadrant 4. So this would be theta, and so theta's reference angle would be between the terminal side and the x-axis. So I'm going to highlight those. So here's theta. And here's theta's reference angle. Okay. All right. So in quadrant 4, if 360 degrees minus theta reference will give you theta, or 360 minus theta will give you theta reference. Again, a lot of times, just when you're working with problems that require this knowledge, if you draw the picture, it's usually pretty easy to figure it out on your own. Now, what I do want to talk about here is that in quadrant 2, theta is an obtuse angle. In quadrants 3 and 4, theta is a reflexive angle, because it's greater than 180 degrees but less than 360 degrees. Of course, it doesn't have to be reflexive. If it spins around multiple times and it does more than one revolution, that of course is not true. But in these pictures, we're looking at obtuse angles and reflexive angles. Now, I didn't mention quadrant 1, but I'll go ahead and we can talk about that. If we have an angle theta in quadrant 1, theta is also theta reference. So they're equal to each other, and that is because theta in quadrant 1 represents an acute angle for the most part. Okay? So in quadrant 1, theta is acute. Theta equals theta reference. So that's your information in regards to your reference angles. Now, why is that important? If I'm asking you to find a measure of an angle, say I'm going to be doing this down here in example 9, the calculator doesn't know what angle you're talking about, because there are multiple angles that have a sine of 1/2 or a sine of -1/2. In fact, on the unit circle, there's two angles that have a sine of 1/2, a sine of theta that's 1/2, and a sine of theta that's negative 1/2. So the calculator, when you're looking for an angle measure, will only ever give you reference angles. That's all it'll give you. Or, well, sometimes if you're looking at a cosine of theta, it'll give you between 0 and 180 degrees, because cosine's got a different little situation going on, but we'll talk more about that in a little bit. Okay, so here let's just look at a couple of examples. So here in example 7, it says find the sine, cosine, and tangent function values for each of the following. Okay, so when I look at 225 degrees, well, if I'm in standard position, then that's going to be here, dead center, between 180 degrees and 270 degrees. So this is 225 degrees. Well, if I was talking about that reference angle, in order to find theta reference right here, which is the angle between the terminal side of 225 and the y-x-axis here, that would be a 45 degree angle, right? And so that would be your reference angle. And if you recall, on a 45, 45, 90, that our sides are, we put this on the unit circle the other day. So our x-coordinate and our y-coordinate are the square root of 2 over 2 and the square root of 2 over 2. But here we are over here in quadrant 3, and so the prefix of those values have to both be negative, because we're going left square root of 2 over 2 and down square root of 2 over 2. And that's going to put us here somewhere with a radius of 1. Okay, so if I'm looking for the cosine of 225 degrees, if you recall the other day in our unit circle, we talked about the x-coordinate representing the cosine of that value and the y-coordinate being the sine. So the cosine of 225 is negative square root of 2 over 2, and the sine of 225 is also negative square root of 2 over 2. To find the tangent of 225, if you recall yesterday, and I better put degrees on that so it doesn't say radians, I apologize. Tangent of 225 is the sine of 225 divided by the cosine of 225. And so you imagine that I divide that number by itself, I get 1. And so those are your values for cosine, sine, and tangent of 225 degrees. Okay. So here we have negative 780 degrees. So we're going to draw a figure showing the terminal side of a negative 780 degrees. Now here's what we know. Negative 780 degrees, if I were to rotate around 2 times and times 360, that would get me, that's 720. That would take me to a coterminal angle of negative 60 degrees, which is about right here, right? So this is just a negative rotation, 1, 2, and then right there. So there's negative 780 degrees. And so what we have here as a reference angle is a 60 degree angle. And so if you recall, if we have a 60 degree angle in standard position with a radius of 1, our opposite is the square root of 3 over 2, and our adjacent is 1 over 2. And so our coordinates here in quadrant 4 would have a positive x value and a negative y value. We just want to make sure we're paying attention to the prefixes that are necessary. Okay, so remember that cosine is positive in quadrant 3 and sine is negative in quadrant 3. So be really careful about that. And again, you can go ahead and use your unit circle for this. You just have to figure out what quadrant you're in and what your reference angle is. All right, so now we'll go and find our cosine of negative 780 degrees, and that is 1/2. And your sine of negative 780 degrees is negative square root of 3 over 2. And then your tangent of negative 780 degrees is your sine of negative 780 degrees divided by your cosine of negative 780 degrees. And so that would be negative square root of 3 over 2 divided by 1 over 2. We'll cancel those 2's and simplify that to the negative square root of 3. And so you have one. Those are your 3 values that you were asked to find for that angle. So for example 7, those angles actually did end up being values or angles that were represented on the unit circle after, well, the first one's actually on your unit circle, 225 degrees, negative 780. You had to do a little bit to figure out it's representative of, I think, a 300 degree angle. Okay, all right. Let's take a look at these next ones. So it says function values for any angle. So it says find each of the following function values using a calculator and round the answer to 4 decimal places where appropriate. So the cosine of 112, the only thing you have to do is make sure your calculator is in degrees. So I'm going to go ahead and pull up my calculator here, and I'm just going to type in, well, I don't want that. Okay, here we go. So we're going to type in, make sure I'm in degrees here. Let me check my mode. It is in radians, so we do not want that. Degree, cosine of 112. 4 decimal places, negative 0.3746. So we get approximately negative 0.3746. Let me just mention on your homework, if you don't put a 0 in that place, and then a 1's place, when there's not a value there, it's going to be marked wrong. Okay, and 4 decimal places, 4, even if the number in the 4th decimal place is a 0, put it. If it says 4 decimal places, go to 4 decimal places. Okay, secant of 500. Our calculator doesn't have a secant button, so remember that that is the same as 1 over cosine of 500. So we'll go and plug that into the calculator. So 1 over cosine of 500 pardon me, you get negative 1.3054. So this is not too difficult here. Negative 1.3054. This next one, you would just plug into your calculator exactly how it says. So I'm just going to give you the answer here. It is approximately negative 8.6427. For cosecant of 351.75, you are going to have to plug in 1 over the sine of 351.75, and you're going to get approximately negative 6.9690. Notice I went to 4 decimal places. All right, cosine of 2400 is negative 0.5 to 4 decimal places. To 4 decimal places. So that one must be on your unit circle after a number of rotations. And then this one here. So remember, if you don't have the DMS button, you're going to have to do the sine of 175 plus 40 divided by 60 plus 9 divided by 3600, just to convert your minutes to a degree and your seconds to a degree in order to get a value. Unless you can plug that into your calculator, value here is 0.0755. Okay? And I'm just going to double check that real quick so that I'm sure that I didn't give you bad information. Yeah, it's correct. Okay, last one here, you have cotangent of negative 135. Now again, this one feels like it'll be on your unit circle because there's a 135 degree angle on your unit circle, so there's a negative 135 degree angle, but it says we can use our calculator. And so when we plug that into the calculator, here's what we get. It equals 1. So we would go to 4 decimal places. It equals 1. Notice I didn't put approximately. Same thing on E. It equals exactly. So you would be an equal sign for that. All right, and so those are just some practices with your calculator. I think most importantly, just remembering how to plug in your reciprocal functions, secant, cosecant, cotangent, etc. And for cotangent, actually, I should write this down. It's equal to 1 over tangent of negative 135. So let's go back and make sure that we're paying attention to that. All right, so here's the thing that gets really tricky and where the reference angles really come into play. Okay, calculators can only find reference angles. Except when we're looking for cosine. When you're looking for cosine, the calculator will give you between 0 and 180 degrees for cosine. But for sine and tangent, it's going to give you anything between negative 90 degrees and 90 degrees. And those are going to be, those are the only angles that a calculator can tell you. So if you want to know theta, and it looks like this, oh, you know what, actually let me put it in quadrant 3 because the calculator never gives you an answer in quadrant 3 for an angle measure ever. So if you want to know theta, you want to actually know what theta is, then the calculator is only going to give you a reference angle. It is only going to give you theta reference. That's it. It's just going to tell you 40 degrees or 35 degrees. It will not give you an angle measure in quadrant 3, or for cosine, it won't give you an angle in quadrant 3 or 4. For sine and tangent, it won't give you an angle measure in quadrant 2 and 3. It's kind of tricky. I'm going to show you here in just a second. Okay, so if you want to know theta, realize that the calculator gives theta reference. Okay, it's going to give you a different measure. Okay, so let me explain why real quick. So let me just go to my unit circle here and explain. So let's say that I said the sine of theta equals 1/2. Well, here's the issue. On the unit circle, the sine of theta equals 1/2 is 30 degrees, but it's also over here on the other side at 150 degrees. Calculator doesn't know if you're talking about a 30 degrees or 150 degrees or possibly 390 degrees, because you know you can rotate around these circles multiple times and get massive angle measures. The calculator doesn't know what angle you're looking for, so it's only going to give you the reference angle. Now for sine and tangent, for sine and tangent, the calc is going to give answers in quadrant 1 and quadrant 4. And it'll give you a positive angle in quadrant, if it's in quadrant 1, it'll give you the positive theta reference. And if it's in quadrant 4, it'll give you the negative theta reference. So for sine and tangent, the calculator will only tell you angle theta in quadrant 4 and quadrant 1, anywhere between negative 90 degrees and positive 90 degrees. That's it. For cosine, the calculator actually will go all the way across from 0 to 180 degrees. It will give you all the way to 180 degrees because cosine is positive here, and then it is negative in quadrant 2. And so the calculator will give you answers for the cosine of theta, for theta, if you're using the cosine function, cosine inverse, in quadrant 1 and 2. All right, so let's take a look at these problems. They're probably the trickiest ones. It says given the function value and the quadrant restriction, find angle theta, find theta. And we'll go to 2 decimal places. Okay, so it says sine of theta equals 0.2812, and theta is in quadrant 2. So the first thing I would do, you can see that it's in quadrant 2 because theta is between 90 and 180 degrees. So I actually like to sketch that out. That's very useful information. Okay, so there we have it. So we know theta is over here somewhere. So theta is going to be some obtuse angle, right, between 90 and 180 degrees. So I'm going to take sine of theta equals 0.2812 and isolate theta by taking the inverse function of 0.2812. And I'm going to pull up my calculator and we're going to get theta's reference angle. All right, theta's reference angle. So here we go. Sine inverse of 0.2812. Okay, so watch what the answer is. It says 16.33 degrees. Okay, 16.33 degrees is not in quadrant 2, right? It's not. So theta's reference is what we're getting. 16.33 degrees. I'm going to put an approximate there. All right, so basically theta's reference, so here's the terminal side. To do reference angles, remember you got a terminal side, so here's angle theta. The terminal side and the x-axis make your theta reference. So this measure here is 16.33 degrees, which is what the calculator told us the value for sine of theta was. Okay, or that the value of theta was. And so what you're going to have to do, come back up here, you're going to have to do this measure here, 180 minus the theta reference, to get angle theta. So we're going to do 180 minus 16.33. So I'm just going to pull my calculator up and do 180 minus and grab my answer there and enter and hit enter, and we get 163.67. So our answer here would be 100 and what was it? 63? Oh, I forgot. 163.67 degrees. I'm going to put an approximate on that. And there you have it. Okay, the calculator gave you theta reference. So you have to engage your brain. The calculator can't think about that measure for you within that restriction. Okay, so let's look at this next one. I think I'm going to do another one with cosine, just so you can see what happens when the calculator gives you an answer, say, and I want an answer in quadrant 3, but the calculator gave you an answer in quadrant 2. Okay, so let's work on this one. We want to find theta, and we are in quadrant 3. So we know we're in quadrant 3 because that's our restriction. Theta has to be between 270. Let's go to quadrant 4. That's quadrant 4. All right, try again. Okay, that's quadrant 4, right? Theta is between 270 and 360. All right, so that measure, our theta should be in that measure. Okay, so first of all, cotangent theta equals, we don't have that button in our calculator, so we're going to have to do the tangent of theta is equal to the reciprocal value. So I'm going to have to take and flip my adjacent over opposite to my opposite over adjacent, and then take theta, the tangent inverse of that value, -1 over 0.116. Oh, that's too many ones. Let me clear that up. There we go. Sometimes there's too many ones. All right, so I'm going to plug that into my calculator. So let's go tangent inverse of negative 1 over 0.1611. And we're going to get a measure of negative 80.85 degrees. All right, so this means that we're coming around here and stopping somewhere right here. So this gave us negative 80.84. So theta's reference angle is just an 80.84. You're just going to go with the positive version of that angle. So that's this measure here. Okay, so all we have to do to find the angle theta, if our reference angle here is 80.84 degrees, we're just going to subtract 80.84, our reference angle, right? That's our reference angle. Let's see what we did in quadrant 4. So we have 360 minus our reference angle gives us angle theta. Again, common sense will tell you that. So I'm just going to go back to the calculator and do 360 minus, capture that answer and input. You know what, I should probably just put not a negative on that, so let me get that negative off of there. There we go. And that gives us 279.15 degrees. So 279.15 degrees. So angle theta is that measure. Let me put a degree mark on it so that we make sure it's a degree and not a radian. All right, and so that's how you would do that one. Now, I really think I probably should add, I was thinking about this a little bit earlier, that I really should add a cosine example. So let's do a cosine example real quick. So let's say we have the cosine of theta equals negative 0.35. We'll just keep it simple. And we're going to be in quadrant 3. So theta is going to be, so we'll go from between 180 and 270. So we're going to stick in quadrant 3. Okay, so what are we going to do in regards to that? Because if you recall, I told you the calculator won't give you an answer for theta in quadrant 3 ever. And with cosine, you get that special situation where the calculator will actually give you an obtuse angle if your cosine is negative. So we're going to plug that into the calculator. So we're going to do theta equals cosine inverse of negative 0.35. So we'll plug that into the calculator. So second inverse cosine of negative 0.35. Hit enter, and that's a 110.49 degrees. 110.49 degrees. So you can see what the calculator is giving you. It's giving you this angle as a reference angle. The calculator gave you theta equals 110 point, what was it, 49 degrees? Yes, 49 degrees, 0.49 degrees. That's what it's giving you. But you have to find theta reference because we're trying to put this angle in between 180 and 270 degrees. So what we're going to have to do is take 180 degrees minus 110.49 so that we can get theta reference, and then we can graph theta in the next quadrant. And then we're going to double check it to make sure it's true. So let's go to our calculator and do 180 minus our last answer. And that gives us a reference angle of 69.51. 69.51. So theta's reference angle, 69.51. Okay, so now what we have to do is we have to take that same reference angle and we have to transfer that measure down to here between 180 and 270. So what we're going to have to do to find theta now is take 180 degrees plus our reference angle of 69.51 to find angle theta. So we're going to go back to our calculator and go 180 degrees plus we'll grab up that reference angle there of 69.51, and we get a 249.512668. Okay, so we're going to check this to make sure it's right. So theta is equal to 251 point, what was it? I already forgot. 249.51. Wow, I already forgot what it was again. 200, don't get old, 249.51. So let's clean that up. 241.51. All right, so now what I want to do is check to see what the cosine of 241.51 is. So I'm going to plug that into my calculator to make sure that I get back to this value here. So I'm actually going to plug in the exact value that I have here. So I'm going to do the cosine, and I'm going to grab that whole value up there, and we should get a measure of negative 0.35. And so that's a good way to check your answer to make sure that it is correct. And those are a little bit tricky. And so that's how you do today's assignment. Good luck. We'll see you guys